Hi everyone, what should we do for our math project this year?
Well, I come across with an article by Frank Kelly from Princeton University about solving traffic problem with mathematics, in particular using Lagrange multiplier together with matrix operations.
Oh, it's a good idea. There are many bad effects of traffic jam, like wasting precious time and fuels.
So how can we solve traffic problems with Lagrange multiplier?
Well, in real-world traffic problems, it's rather complicated, so let's look at a very simple case first. Let's assume that in our traffic system, there are only two places, A and B, connected by two ways, lane 1 and lane 2. T1 is the time taken for each vehicle travel from A to B by lane 1, where N1 is the number of vehicles using lane 1. Similarly, T2 is the time taken for each vehicle travel by lane 2, and N2 is the number of vehicles on lane 2. Therefore, T is the total time taken by all vehicles in this traffic system.
So, how do we proceed from here?
Well, we need to find the minimum value of T, which in this case is the minimum total time taken. We may first form the equation for lambda using Lagrange multiplier, then perform partial differentiation to obtain the system of equations, which we will then solve.
So based on the method, we should have N1 equals to 40 vehicles using the left road and N2 equals to 60 vehicles using the right road.
That's a good idea, but how do we apply to real-life situations? We may be able to suggest some good ideas for LTA to consider. Reducing waste of fuels and precious time is important to our modern society.
Currently, in our RV school Boone vicinity, we always heard of people complaining that there is always heavy traffic congestion on the roads leading to PIE entries and NTU campus in the morning.
For our case study, the starting point will be at point A, which is near Jurong Point, and our destination will be at point D, which is the entry point to NTU campus. Along the way, we will need to study the use of different roads leading to NTU entry point.
Sounds good to me. With school holidays coming, we'll split ourselves into two groups and proceed to gather all the necessary data for the 5 roads identified. We have studied the red, green, and purple road. Here is the findings.
We have also collected the data needed for the coffee and blue color roads.
Well, we perform linear correlation test of data using Microsoft Excel to obtain the estimated time taken formula for vehicles, where X is the number of cars and Y is the time taken by each vehicle.
How can we use Lagrange multiplier to solve problems in our case study?
Well, let me explain to you.
With all the 5 equations, we are now able to analyze the traffic situation in our case study area with an estimated number of 18,050 vehicles leaving point A every morning from 7 to 8 a.m. They will return into either the green or the red road. For those who use the red, they will then naturally proceed to the blue road and to NTU entry point.
Note that using Lagrange multiplier approach, we form the necessary equation for lambda A. By performing partial differentiation and solve the partial differential equations with a constraint of xr plus xg equals to 18,050, we obtain the optimal number of cars, that is approximately 890 for the red, and 17,160 for the green colored road, and with this, the total time taken will be minimized.
By applying the same method, we can work out the optimum number of cars for the remaining roads.
Well, putting all our findings and results together, we have the following proposal for LTA for the traffic flow from 7 to 8 a.m. in our case study area. We perform simple calculus check for the local minimum effects.
With these figures, LTA will look into ways like changing the time for traffic lights or using more traffic lights to maintain the desired number of vehicles in each road.
For more complex system, we will still propose to use Lagrange multiplier approach in forming the relevant equation for lambda with consideration of all necessary constraint Ci's. We can then apply complex matrix operation approach to find the optimum number of vehicles for each road by solving the system of equations obtained by applying partial differentiation.
I think we can see what we are fast working this project with the useful and realistic results obtained.